We want to find constants c and d such that the function f of x equals c sine of x plus d cosine of x satisfies a differential equation. Okay, first we need to find what f prime and f double prime are, so we can plug it into this differential equation. So if f of x is c sine of x plus d cosine of x, f prime of x will be c cosine of x minus d sine of x. And then the second derivative is negative c sine of x minus d cosine of x. Now we can plug it in. So for f prime, it's c times cosine of x minus d sine of x. And that's going to be minus twice f of x. So that's c sine of x plus d cosine of x plus f double prime. It's negative c sine of x minus d cosine of x. And then we're going to set that equal to sine of x. At this point, we want to simplify this. So we can group the negative c sine of x. And here we have a negative 2 c sine of x, and here's a negative c sine of x. So we'll have negative 3 c sine of x. And then same thing here, we have negative 2 d cosine of x, and then a negative d cosine of x. So that would be negative 3d cosine of x. So right now we have c cosine of x minus d sine of x minus 3c sine of x minus 3d cosine of x. And that's going to equal sine of x. So now we can just factor out the sine of x's. So we'll have negative d and then minus 3c. And then with cosine of x, we can factor out a c and a negative 3d. So we set that equal to sine of x. And notice that the coefficient of sine of x is 1. So for here, we'll set negative d minus 3c equal to 1. And there's no cosine of x, so you can think of this as 0 cosine of x. So in other words, c minus 3d, or negative 3d plus c, is equal to 0. Now if we multiply the top by 3, we get negative 3d minus 9c equals 3. And then negative 3d plus c equals 0. Subtract these and get negative 10c equals 3. So then c is negative 3 over 10. And we can plug that into this equation, the second one. We have negative 3d minus 3 over 10 equals 0. So we'll add the 310 over. Divide both sides by negative 3 and get d is negative 1 over 10. And that's our answers.